development company in India, having many first in India products under its portfolio. Having a BTech in mechanical engineering from IIT Ropar, he started his career as a CAE analyst at Time Tooth in 2012. He has led teams through various aerospace and defense projects from conceptualization to qualification to rigorous standards. He compared the hazards of air pollution. He founded Persian Innovations in 2017 and worked on medical devices development with alumni from IIT, Ames, and Stanford University. Off work, he plays games digitally with the code name ABC Dude. Welcome, sir. And next presenter is Mr. Shashank Tyagi.
Yeah, please carry on.
Next presenter is Mr. Shashank Tyagi. He is a project engineer at Time Tooth in new product development. He did MTech in mechanical engineering from IIT Ropar in 2019. He then joined Time Tooth as a fresh engineer. In a short span of just over a year, he has already worked on multiple projects, including development of a mission critical system for Indian defense. He is currently leading the multidisciplinary development of a medical grade product. Today, they will take a session on the joy of development and
Bhutinder, I think I missed your voice, but maybe it is only me.
No, sir, actually, it was some technical error on my side, some network issue. We have Mr. Yogesh, a core engineer at HERT. Mr. Yogesh is currently Vice President of Engineering at TimeTooth, which is a leading CAE-driven turnkey engineering product development company in India, having many first-in-India products under its portfolio. Having a BTech in mechanical engineering from IIT Ropar, his career started as CAE analyst at TimeTooth in 2012. He has led teams through various aerospace and defense projects from conceptualization to qualification to rigorous standards. He compared the hazards of air pollution. He founded Persian Innovation in 2017, worked on medical devices development with alumni from IIT, Ames, and Stanford University. Off work, he plays games digitally with the code name ABC Dude. Welcome, sir. We have another presenter, Mr. Shashank Tyagi. He is project engineer at TimeTooth in new product development. He did MTech in mechanical engineering from IIT Ropar in 2019, then joined TimeTooth as a fresh engineer. In a short span of just over a year, he has already worked on multiple projects, including development of a mission critical system from Indian Defense. He is currently leading the multidisciplinary development of a medical grade products. Welcome, sir. They will today take a session on the joy of developing an engineering product.
Hello everyone, thanks a lot for the introduction. I hope I am audible and you can see my screen.
Yes, sir, it's perfect.
Okay, great. So virtual internships. So when Dr. Dheeraj mentioned it to me a couple of weeks ago, and I was just really fascinated with the idea of even having internships virtually, and it is really an honor to present at an event organized by my alma mater, IIT Ropar. So just glad to be here. So we will be talking about the joy of developing an engineering product, which for us is basically the whole engineering product development cycle. So we will be your presenters for today. I am Yogesh Agarwal. I graduated as a bachelor in mechanical engineering from IIT Ropar in 2012, and as a fresh engineer, I joined TimeTooth as a CAE analyst, especially in the multi-body dynamics domain, where I worked on a lot of projects. But the one that is the highlight is the development of a landing gear for Rustam 2 that was being developed by DRDO. So I led the team that basically went from the conceptualization to the qualification testing and then actually being installed on an aircraft that flew. So, and after that, air pollution was rising a lot, especially in Delhi NCR. So I got motivated to, that we should do something about it and as an engineer, I wanted to contribute there. So with with my teammates from Ames and Stanford, I co-founded Persepian Innovations, where we developed devices to combat air pollution. So I was there for about 4 years, but then I was doing something great, but my love of engineering has brought me back to time tooth, and let's see if I can contribute in helping you be a better engineer. With me is Shashank. He has just recently joined Time Tooth, but he is already a rising star. So I'll let him introduce himself later when he presents his part. Okay, so just briefing you about Time Tooth. So Time Tooth actually started in India around 2007, 2008, when CI was still in a nascent stage in India, but what TimeTooth wanted to do was bring CI into the critical path of product development. There were tools available, but it was still not something that was being used to develop a critical product. So it was founded by alumni from Michigan University and IIMA, and TimeTooth has been working for 13 plus years now in the domain of engineering and design solutions. We have developed a lot of aerospace and defense product, and we basically take pride in using those simulation-driven techniques to get first-time right solutions. Uh, we have delivered a lot of products in greenfield or blue ocean markets in the fastest time frame. So, in fact, during the development of the landing gear, we are the first private company to have developed a landing gear in India. And while HAL did it in, I think, 10 plus years, we did it in 1.5 years. So, and we have built such an ecosystem that we consider ourselves a single window into system engineering and an integrated product solution. So, what is the agenda of the session? Uh, Okay, so let me go back in time. When I was a first year engineering student, and we had a professor from IIT Delhi, Dr. Kale, and a lot of us mechanical engineering students were interested to participate in Baha, in some robotics competitions, and we talked to him about it. What he said was, I mean, this is all rubbish. Why do you want to participate in these competitions? They are fairly easy. Which he was surprised. And what he said was, if you develop something that can be used in a critical application, can you develop a robot that can probably be used in a nuclear reactor where a human can't go? So that would, I guess, be the real success of being an engineer. And after that time, for a long time, I wondered, what does it take from, just that project or a competition product to such a critical system. Uh, and I think I can say with my experience at TimeTooth and working with a team that has worked on a lot of mission critical systems, uh, me and Shashank will try to communicate what is that difference between being a student and a product engineer. So, so because I talk of mission critical products, I will just breeze through some of uh, the products that TimeTooth has developed. What you see in front of you is a moment of inertia and center of gravity measurement machines that is typically used for missiles and space systems. So Shashank will actually talk about this system in detail a lot more. So I just skip this one. We have developed blast resistant seats that actually have to uh, absorb the impact of a blast on a combat vehicle or a helicopter crashing down and still protect its occupant from that shock. Uh, so this is fairly interesting and recent. So an inventor came to us. He was very passionate that people who have spinal cord injury or people who have suffered from a stroke are not able to mobilize their limbs. So can we develop a rehabilitation system from them? So here we went from the basic scratch idea to a fully functioning demonstrated product that is now undergoing medical certification. And I don't know if you can tell from the images, but it uses tens of motors and actuators and a lots of sensors, so that are integrated with a control device which controls all this, and later will have machine learning capabilities to actually aid in the rehabilitation of a patient. Uh, this is the landing gear that I worked on, and then a lot of team took it forward. Last year when COVID hit, so we Time Tooth was also faced with the question. So we are really good engineers, but how can we contribute into improving the health of our country, and how can we aid in such a pandemic? So what we started working on was developing a ventilator that is not just functional, but takes care of all the safety, security, and the medical grade requirements. So we have already prototyped and demonstrated this product. It is also now undergoing the medical certification. So basically just saying that India, I mean, we have very good engineers, we can develop products, but just moving on from that jugaad thing that people associate India with, and actually developing a global uh, a best in world type of a product that can compete with even the most premium products available in the market. Okay. So what is this transition between a student and a professional engineer? So, so if I have to summarize, it is primarily that a lot more stakeholders are involved in such a project. I mean, in college, the people involved would be maybe your team of students and a professor. But here there are real stakeholders, like there may be an end user, there may be a client or the organization that you are working for. Uh, there may be even more stakeholders, like maybe investors or stuff like that. Uh, Product development in an industry is a very time bound and a cost bound affair, because you are constrained by the budgets. You have to get the product into the market as soon as possible. There is a very multidisciplinary mindset that is required to work on an engineering product. Um, there are obviously, I mean, you might have reviews and your BTP reviews and all that, but that just takes on a whole different meaning when we go into the real life. So we have reviews throughout the process, and taking that customer feedback and in and integrating that into our design process. I just noticed there's a chimpanzee on the left. So my colleague who put the image there, I don't know what he had in mind. So if anyone takes offense, just contact me after this meeting, and maybe we can go beat him up together. Okay, so I was thinking of going through the design process, but wait. Uh, so I have also been thinking, like, through this session, we will obviously be covering the product development and the engineering process. But what is it that I could contribute in your journey as a student, as as an engineer, that would help you learn better? So what is that? So I am sure some of you take notes whenever you are maybe listening to such a session, listening to a podcast, maybe an audiobook, or reading a book, or reading any comprehension. So one is, I would definitely recommend that take notes. So now, are just notes enough? So notes definitely add some level of engagement over just passive reading or passive listening. But there is a technique I actually recently learned which resonated very well with me, and I would like to share that with you. So when you are reading something, when you are listening to something, the first question you ask yourself is, how can I use this? How can I use this? So that basically activates your creative part of the brain. You should write two, three ideas. So let's say you're listening to this. How can I use this knowledge? If you take notes in maybe a paper, keep your left side of the notes for your notes and the right side for writing this down. How can I use this? So once you have those ideas, once your creative part of the brain is engaged, the next question to ask yourself is, why must I use this? Because we humans are not purely logical creatures. We are not rational. We are driven by emotion. So tap into that that emotion, that the part that comes from your heart, and ask, why must I use it? So once you have that in mind, once you have the brain and the heart in place, you should ask, when will I use it? So you should actually have a plan in place. Is okay, what will be the situation when I will actually use this? So this part is actually blatantly copied. And if you want the link to the full video, I can share that link later. But this is something I found really useful, and I hope you will try to implement it. Okay, so now back to product design. So, so when I was just finishing college, I got placed at Time Tooth, and what I knew about Time Tooth was that they have developed that they have they are very good with analytics, and they have developed some missile launchers for Agni programs and stuff, and that they use simulation engineering to do the product development. So I just found it really exciting, and I wanted to do the most complex simulation ever. And then I landed at Time Tooth. I went through some of the administrative and my training, maybe. And I asked my boss, Girish, so when do I start simulating? He said, wait, first gather requirements. Okay, what does that mean? So, so again, start with why. Because emotions are just really so important. Why does your organization want to do this? Why do you want to build that product? What is the value that you want to contribute? What is the background of developing that product? Then second, what is the objective? Maybe a 1 or 2 sentence description of the product that you're trying to develop. What does that uh, want to achieve? Or even if you're not developing the whole product, if you're just involved with maybe simulating that, write down the objective for that, because having that clarity is just super important. Now that you have the objective, you should define your scope of work and your deliverables. Scope of work means what are the broad areas of work that you will have to do in order to meet that objective. Deliverables are the set of outcomes, like whether your outcome is the result of an analysis, is that outcome a design drawing, is that outcome a prototype, a tested or a demonstration, or is it a production set of maybe a lot of 100 items or whatever that is. So having those in place is the first requirement. Then let's come to the system. So so now we have to look at system requirements in lots of different ways. So one part of it is functional requirements. So so let's take an example of a hand. What is the requirement of a hand? So I could say it should be able to pick objects. It should be able to grip something. So those could be the functional requirements. We could have, as part of our functional requirement, what should be the loads it should be able to meet, what is the range of motion it should be able to do, and all of that. The other kind of requirements could be from a regulation standpoint, from your qualification. What is the standard that your product needs to meet? Requirements could also come from your business. What is the cost that your product can have? What is the maximum cost? What is the time? Uh, or what are those performance parameters that your product needs to meet? So so I did all this. Now the monkey inside me was really, bubbling. Now I have the requirements in place. Now please let me do simulations. So I went back to Girish and I asked him, okay, I am now ready with this. Let me do simulation. He said, wait. Now what you have to do is basically take those requirements and maybe go to your paper and pen or whatever tool you like to use, but have a concept of that idea in place. Maybe do some sketching, have some different concepts that maybe you have some different concepts that you would like to test out. So write those down. And the second thing you do is basically take that system requirement and break it down into the smaller subsystems and components. I'll take an example here. While we were developing the ventilator, we needed to measure the flow inside the tubes. And while we looked for a bought out item, that was really not feasible for for the development that we were going for the performance requirements that we needed. So we actually decided to develop our own flow sensor for this case. So now what we did was, from the ventilator, we knew this is the flow rate that we need to measure. This is the speed, or this is the frequency at which we need to measure it. So now how do we break it down? Uh, okay, so the third requirement is what is the pressure drop that this device can have? Because this is a critical device that is used for a very critical patient. So, so now how does this map to its components? So there is a mechanical part of a flow sensor. So we decided that, these are the requirements for that mechanical part, that it should not create a pressure resistance more than this number. There was a pressure sensor that needed to be used. So for pressure sensor, we had the requirement that it has to measure that very small variation in pressure difference, and it has to have that sampling frequency. Now we needed a PCB because this device now has to interface with the ventilator main control. So what is the kind of interfacing that is required there? So now we have our requirements. So again, I said, now I have the requirements. Now I know what components need to be designed. Now the monkey inside me was really excited. Now is the time. Now is when I get to go on a simulation software and use it. You know what Girish said next? He said, okay, you have the component. Maybe you want to develop a landing gear. So just taking an example. So this landing gear looks fairly complex, right? I mean, it is, but it is complex, yes and no. So there are definitely a lot of complex things that go into actually uh, actually making such a product. But at its core, it is basically an oleopneumatic suspension where there is a gas which is compressed to kind of store the energy, which acts like a spring, and there is oil that flows through some orifice that basically acts as a damper. So this relates very well to something that mechanical engineers might have learned during their coursework. So this is basically a system where there is a spring and damper in parallel. So now, so we don't have to do anything. Just go back to your engineering basics. Maybe use gas law for the gas. Have the flow through orifice modeled as force is proportional to velocity square, and that is where you start. Okay. Uh, so now I had done the basic calculations also. Now I was definitely ready to get into simulation. Okay, so the first question Girish asked me then was, why do you want to use simulation? I said, boss, it's cool. That is the reason I want to do this. I just find it really exciting and really cool. And I still hold on to that. But why do we use simulation? So simulation driven engineering is not just clicking software buttons. It is not about using that UI beautifully. I mean, definitely that is important, but the more critical part of it is actually having those engineering fundamentals and then understanding the basic mathematical formulations, because almost all of the simulation techniques are basically based on some mathematical formulation that is being used. So having that basic understanding is a more critical thing. Uh, so what simulations allow us to do is it can give us out of box designs, which a traditional document process or a traditional engineer would not be able to do. It allows us to have really fast iterations time, and we don't have to really use lots of physical resources. So it saves us money and time. It can also help us test systems that are not physically able to test. I mean, if you ask SpaceX to test every component that they make physically, they would just run into the ground. But what they do is they simulate systems on computers so that they have to do very minimal physical testing. Okay. So now that that is clear, while we go into the simulation, it is really important to understand that what we give into the simulation system is what we get out. If we give it garbage, garbage is what it will output. So first we need to understand what is my simulation requirement in my product, what or my component, what is the kind of simulation that is required. Maybe it is structural analysis, maybe it is static or the dynamic simulation, maybe it is a multi-body simulation that I need to do, maybe it is CFD, maybe I need to simulate my control logic, or maybe I need to test my code and simulate that. So that will depend on the engineering that you are working on. But basically having that understanding and having the relevant portion of the system identified on which you want to apply that analysis is important. Next comes defining your inputs. So first structure analysis, what are the kind of loads that you're looking at? What are the constraints that your system has? What are the outputs of interest? Are you interested in the stresses? Are you interested in the deflections? Or whatever that output of interest is, identifying that is very important. Next, we come to defining the correct boundary conditions. I mean, at time tooth, we can give you zillions of examples where things have failed if the boundary condition was not properly defined. We do the simulation, you realize that it is not working as expected, and you go back to the basics and you see that, okay, I made a mistake there. So having these basic understandings, and the last part is listing down your assumptions, because because basically simulating a real life product into a simulation, you are making assumptions. It may be that your fluid is incompressible. It may be that your material is homogeneous, uh, and it behaves the same way in all directions. So list down those assumptions. How those help is, if your simulation and your real life results don't match, you can come back to these assumptions and then see if there is an assumption you made that was not correct. Okay. So now actually coming to simulation modeling. So simulation, so the main crux, again, as I said earlier, is not learning how to click, but actually having that basic engineering fundamentals and that system understanding to to basically say that this is how this simulation is going to help me. The second thing to do, because computation is something that has increased a lot in the past years, computation ability, but in whatever context you are in, you will always find limitations there. So you want to decrease that computation as much as possible. So you could model something complex with some using some basic elements. Like take the example of a pin joint about which two components are just able to revolve. So a very simple understanding of it could be when you have to understand, let's say, the mechanism or the effect of it on a structure, you could just model it as a pin joint. You just 1 degree of freedom of rotation. If you have to dig something deeper, if you have to go into compliance, or if you have to study the contact surfaces, if you have to design that bolt itself, then you look into contact surface simulation. Now we could also go a step further. If you use some bearings or some non-linear bushings, you may also need to go into let's say structure and hydro interactions. So you have to decide based on your output of interest, what is it that you need to analyze. Okay. So basically that saves your computation power and it saves you time. So these are just some examples. I'll just probably skip through these. So here what we had done was, because contact simulations used to be very difficult in those days, so just modeling it using some spring damper systems or using bushings. Here we use symmetry to actually simplify this system during the simulation, so that that the simulation my simulation software does not have to solve the whole system. Because it is symmetric, I can scale it, I can simplify it for my simulation needs. So now, once you have done the simulation, what is there in the post processing? So you basically have to do a variety of checks. It will again depend on this type of simulation that you are doing, but probably first is check your animation. Is it something that is expected? So if it is not, maybe look back at your inputs, outputs, constraints, boundary conditions, and assumptions. Do a sanity check, verify the loads, or balance the energy in case of maybe static analysis. Verify against, again, going back to those your mathematical calculations that you did, verify against those whether the range of values is matching to those. Check your constraints, boundary conditions. And you can also do something That is basically check the relationships between maybe your input variables and your outputs, or between outputs. Maybe you have also outputted pressure and a force in case of a landing gear. So are they behaving in an expected manner? So this is how you verify that your simulation is working okay. So so now my monkey was slowly learning all how to go through that design. But later I came to know that this has a name. It is called systems engineering, where we have covered the left half of it, but basically going from that conceptualization, feasibility study, to the concept, to the system requirements, to a high level design, and then a detailed design where we use simulations. So the next part comes is actually translating that design into a product. Okay, before that, I think this is something that I have dreaded for the longest time. It is documentation. While I was developing the landing gear, because we had to get it qualified to Similac and DGUK, they had very strong documentation needs, and I just really used to get frustrated. But over these 9 years, through some failures and stuff, I have realized that the importance of it, because one is that you will be doing lots of iterations. You should know what did you change, maintaining that version control. It also helps you debug some issue. So what was the change you did that led to maybe some issue, new issue that cropped up? So you should be able to identify that. So it helps with that identification. Third point is human brains are not made for long-term storage. I mean, when I was developing the landing gear, if you asked me anything about the landing gear, I would be able to give you the exact value in a second. But if you ask me today, I will say, boss, refer to the old documentation. So so basically not repeating that process. It may be that someone else may have to use the work that you did. So they should be able to understand the work that you did. So you should document in a very simplified manner that is easy to understand for everyone. This documentation also allows us to reuse some of the modular elements that we can use in our next development. Okay. So design reviews. So one is, I have been developing engineering systems for 9 years now, but I would still, while doing any design, I would still get it checked internally by a teammate, because humans make mistakes. I mean, there is no harm in admitting that. So having another set of eyes at what you do is really valuable. Then there are various stages. So while going through your design, once you have the concept in place, once you have those basic mathematical calculations, maybe a preliminary design. So that is when you do a preliminary design review to basically gauge whether we are moving in the right direction or not, whether we are capturing the right information, whether we, whether the basic work that I have done makes sense. And also, a linked objective here is to communicate with the client. In our case, it is a client. In someone else's case, if you're working at a startup, it may be your investor, maybe your end user. So having that feedback is really valuable. In some cases, those milestones may also be linked to maybe some funding, maybe the next tranche of your project money, or something else. So having those in place really helps. So once we have that, once we are done with our final design, we have what we call it time to critical design reviews. Uh, so that is basically the whole system. You review it, that before you go for manufacturing or something, that you have done it right. It meets the customer's expectations. Okay, so CAD modeling is something that I did not touch on before, but depending on the type of simulation you did, or uh, you might have already started making a 3D model of the product that you are making. So, uh, so basically having 3D CAD in place basically makes it very visual. Rather than drawing it on a paper, when it's really easy to visualize a 3D product in a computer, you can just rotate the views, do whatever with it. It is very easy to make changes, and it also allows us to study, because most of the products that we make are not single components. They are assemblies where different parts need to interact with each other. So having 3D CAD allows us to do that. It also allows us to easily generate the drawings that are later needed for manufacturing. So So now that we have our basic design in place, how do we go from that design to a product? What I would strongly recommend is if you can get some hands-on experience, if you can get some manufacturing experience, that is really valuable because systems and products cannot be designed sitting in an office, which I realized the hard way while developing the landing gear. So we had made some cool designs. Uh, yeah, but when we went to the manufacturer, he said that this is not possible to make. What are you talking about? So even when you are designing, you should have those constraints in place. Is something that I'm designing, is it possible to be manufactured? Will it meet my cost and time constraints? Which manufacturing technique can be used to make this product? Is it machining? What type of machining? What type of raw material processing or uh, the raw material specifications are required to meet the product that I have made. So having all that in place, the second part then comes is geometric dimensioning and tolerancing. So if you have components that are interfacing with each other, so you have to have very strong knowledge of those, how those tolerances. So those numbers H7, H11 seem very random, but once you have that understanding of a physical system, uh, those things just fall into place. If you have to have something moving, what is the kind of tolerancing you should have? If you have to have a tight fit, what is the tolerancing you need? If something needs to slide, what is the finish that is required on your product? So identifying those critical dimensions and actually identifying those tolerances, if those can be met again by your manufacturer, are some things you need to consider during design. Another thing that comes into play is using standard or bought out components, because you cannot go on to designing everything from scratch. So because of time and cost constraints, it many times makes sense to buy something. So you should also have those availabilities in your head. If the component that I'm using is available, what are the lead times on that? And then coming to the next part is, once I have those components, how do I assemble those? So in your 3D CAD, you could have made a beautiful design, but it is not assemblable. Maybe you put one component inside of another one. Maybe 3D printing could do that, but traditional manufacturing or assembly techniques, you have to be really careful whether it can actually be assembled the way you want it to. Okay. So these are some examples from the landing gear, uh, but basically we while developing that, even though we had a custom requirement, we chose to use a standard tire and a wheel because it would have been just really costly and it would have taken a lot of time to actually develop a wheel and a tire and to get it certified. Um that was similar for some of the connectors and some of the electronics components that we used. So now we can come to the right side of the V. So now we have done everything. We have our design. We have the product ready. So now how do we validate? So what we do is so we basically verify what we designed. So it is a verification and a validation of that. So we test whether the material is something that I had designed for. So let's say I had considered a yield strength of 250, but my material has a lower strength. So that would not work, right? Your product would fail. So how do you verify those design things? So maybe material test reports. You may have processes that you specified. On landing gear, it had to withstand harsh conditions. So we had specified plating, whether it was of the appropriate thickness or not, whether it followed the appropriate governing standard or not. So you need to have those certifications and those measurements. You do on a component level, then you do visual inspection, you do measurements of your critical dimensions. It could be just using a simple ruler to a vernier caliper to very high-end measurement machines, but but that is what you need to do. Then you do a unit or an assembly level testing. Uh, so this is a qualification testing for the landing gear that we developed. Uh, what this helps with is qualification of your design, because especially in such regulated markets, there are entities that would certify your product. So so how do you qualify that product for that specific MIL standard or FAR or being certified by Similac or DGQA? And then to actually test it, you also need to develop your test setup. It should be able to capture what you expect out of your test. So for which there is interdisciplinary requirement of, the structures, the instrumentation, the data acquisition. So all of that is also something that you might have to do. Now this is I think what we say is where we derive value at time tooth is basically how well your simulation correlates with the actual test results. And that is where the beauty of following all these processes are. You could just click in a simulation and be nowhere close to a physical product that you make. So so having all those basic processes in place and basically having this correlation is what I feel is just really beautiful. Uh, and then once you have a correlated model, you could actually use it for similar products for future. And at time tooth, we claim that we have very high correlation percentages, and that is why our customers are able to rely on us on just using simulations, our simulations, to even validate some products. Okay. So so now this is something that has changed, and also basically where simulation helps. Earlier, what we used to do was, let's say we have our design, we have to make a product, we have to make a prototype, and then once we test it, we know what design changes are required. So now simulation allows us to do that just on the left side of it, basically virtually building and testing it and optimizing it. But once you do the testing, you can also go back to your design, improve it, and then retest it. So I have primarily covered the product development cycle, but there are also other things that you need to think of once you think of a product life cycle. So after your prototype or your proof of concept is made, validated, tested, you go into a real life use. You have to also think of whether it is maintainable, what will be its operations, how will it be used. Later, you might need to make changes and upgrades to it. So how do you do that? In the very end of your product life cycle, you may have to retire the product or replace that product. So that is basically the whole product journey. I will not go into those details right now. So moving next. So I think most of you would want to ask me, you say that this is the joy of building an engineering product, but where is the joy? You take me through so many boring steps and then say building an engineering product is a joy. But the joy is in actually following those small steps, and then when you make that product, when you see that when we did landing gear drop test, it matching exactly with what I had designed in my simulation. So the DRDO lab had also invited us when Rustam 2 first flew, and when I and Girish were there, and when we saw it fly, take off, and then land on our landing gear. I mean, I just cannot describe the excitement that brought me, and the satisfaction uh, that it that I felt. So this is just a video of the drop test that we did for the landing gear. So basically, this is making sure that my product will succeed in the field. So now I'll hand it over to Shashank, who will guide you through his product journey. I mean, I have explained you the boring concepts, but I feel that it will be interesting to actually know Shashank's journey through a product development and applying these concepts there. Over to you, Shashank.
Daminder, can you unmute? I think Shashank, you can unmute yourself.
Yeah, I think I'm unable to share my screen.
Okay, just wait.
Just assign it.
Yeah.
Thank you, Yogesh. Wonderful journey, I think.
So you are the presenter now.
Yeah.
Yeah, thank you. So yeah, hi, good morning, good afternoon. It's a Sunday afternoon. Maybe good afternoon to most of you, and for me, it's still a good morning.
Okay.
And I really hope you are all doing safe, well in this pandemic. And it's around 1 o'clock as well, mostly the lunch time as well. For me, it's lunch time, but today it will be a breakfast time. And many of you might be having the lunch in between the discussions only. Like I do it very frequently during the meetings, just turn off the camera and do the lunch. So during this discussion, many of you might be having lunch also. So just to tell about me, I belong to India's most well-organized and well-managed city, Meerut. And I post-graduated from IIT Ropar in 2019, just exactly 2 years back. Yesterday only I got the notifications of Google Photos memory. Just exactly 2 years back, I I left IIT Ropar and then I was placed at Time Tooth. I joined here, and today I will be sharing my personal journey from a college project. This was my first project at Time Tooth. What all I learned, how did the product development went from the initial, and how did I went from learning to that execution part and the final delivery. So I will go through my project, and this project is generally, like Yogesh mentioned, about movement of inertia measurement machines. It is a very critical part of India's defense program already, and can be used at many places also. I will go through once. So firstly, I will take you. ये मैं हूँ, ये मेरा टेबल है और यहाँ टेस्टिंग चल रहा है. And this table actually looks very messy, but as soon as I sit here, as go to the office and I sit here, I'm at another level. I go thinking that I will do this, but when I sit here, I keep things messy. On Monday, I clean it up, but till the time it comes Saturday, it is all full messy. I keep the instruments there only. So I, this is my messy table. I sit in between that, and yeah, it's really a great experience. And when we sit here and look this around testing set, it is a really great experience. So, like Yogesh has already told you about this product development roadmap. It starts with a design feasibility research. We will go through once when we go through our actual what we did in feasibility research and all. Then we have to do this, freeze our design specifications. Then we have to conceptualize our design. Then we have to make a preliminary design, and then we will come to simulations. When we will come to subsystem prototyping, a subsystem level, then we will make a detailed design. Then we will procure the components and do it for manufacturing. Then we will integrate and test. And if there is some issues with the testing, then we redefine it and retest it. And the final stage was delivery, installation, and commissioning. And like Yogesh mentioned, at every step you have to do documentations. And for me, it's a very boring thing to do because everything you have to note down. It is actually a good thing to note down, but for me, it was a very boring thing to do because to make long documents, to do how do you think, how do you approach. And just after this product development roadmap, we decided, we made a time plan. We thought of we will completing everything on time. Everything looks so good. Then we all discussed and said, must plan hai. literally everything looks so good. We will just doing everything on time. Some every dates were assigned, what we'll do, when we will do, and what will be the procedure. And this was our discussion, maybe our snapshot only. So yeah, the first step was the design feasibility. Of course, when you start product development, you have to think, why are you making, that Yogesh mentioned, the need, the requirements. So when I started studying about this center of gravity and moment of inertia machines specifically, so we found that this missiles, aircraft, UAVs, and some space missions, except UFOs till yet, then there's a requirement of center of gravity coordinates and the requirement of inertia coordinates, and these are the very important part for like to control the mechanics, to control the position and the direction of a missile or a rocket or a UAV. So this becomes very important to actually know these coordinates. But then there was a news, I think last year, last month only. So I will just play this video. It's not a Diwali firecracker. It's actually a missile, Russian missile. It was launched and tested. So when it went up, it started spinning about some direction, and then it started spinning after long, and then it fall down into the ocean. That possible reasons, there can be many reasons for it, technical failures, but generally to control its direction, just think of something. You have to give a force, a vertical force, and is instead of giving in the direction of center of gravity, you give it with the offset. Then what will happen? It will create a moment and it will start spinning. So that is why it is very important to know the center of gravity, the moment of inertia of any object flying in the air. Then still, like, there are lots of ways of measuring center of gravity, moment of inertia, moment of inertia coordinates. The first one is manual calculations. That is very difficult to calculate manually for very complex designs. The second one is the modern CAD softwares. You can get the coordinates of inertia values and CG coordinates just by drawing these CAD designs. But what is there is you cannot, the first thing in manual was you cannot measure accurately with the complex object assemblies. And also when you assemble a whole system like a missile, actually it is very tedious to accommodate everything. Like there will be electronics, wires might be lying here and there, harnessing, pneumatics. So, and there will be non-homogeneity in manufacturing also. So what will happen, the CAD software, CG coordinates or inertia coordinates might not be valid for the actual product. So yes, then there was a need. We got a project for this manufacturing and design of center of gravity and moment of inertia machines. Then we started to look into what specifications we want to put into our machines. Then we decided, we thought a little what all features we want. The first, I distinguished between two parts. The first one was the measurement features. The other was performance features. In that measurement features, like it should be a very high accurate, because that is what we are targeting the most. As CAD software is already giving us inertia values, it should be having a software. It should be just giving a direct value into the software. We don't need to manually calculate or do anything. We should be having a good graphic user interface, and in performance, it should be a very stable, because you will be handling various space components or defense components. It should be very rigid, robust, durable, and very safe as well. And design should be very compact. So these all features we wanted to put initially when we started thinking to build our own center of gravity and moment of inertia machines. And then we targeted some physical aspects of it, physical specifications, like in that CG measurement machines, what will be the range of CG we can measure, what will be the accuracy we can claim, what will be the mass accuracy and inertia again, what will be the range of object, how big object we can put on our machine, what will be the inertia range, and what again will be the accuracy. So these are all specifications we built and documented once. Then we started working on the design conceptualization. Yeah, like Yogesh has already mentioned you about the weight and weight scenarios of simulations. So this is the third stage, design conceptualization. In this, I will not go through the center of gravity and mass machines. I will just go through a one roll inertia measurement machine because there will be a lot of things and a lot of structure to put over it. So the first step in design conceptualization is ideation. So whenever like, I will take myself, I will go to the books, I will read the research papers like a bookworm, as you can see, although my specs don't match this picture. But still, to make an idea, to make a concept, I will go to the books, I will read some articles, I will search for things, and I will really hope I get something very related to this. This whole ideation works, then we'll come into some, we'll structure that part, what you always read, and then what I did was I did not get that thing like to get and measure accurate inertia things. So I went to my book and wrote down a very simple equation like a torsional pendulum equation because that is what we want to measure inertia. And I took this concept from theoretical approach to measure the time period, which is dependent on inertia and the stiffness, then to design the conceptualization, then and we decided that this time period can be measured by a time period sensor. Stiffness of our machine will be known, and then we have to just calculate the inertia. A very basic equation. We will oscillate it and measure the time period. The stiffness will be known, and just calculate the inertia. That was a very theoretical approach. And while going through research papers only, we got 3-4 already concepts which were used or which were there discussed at some places. The first one is the trifly method in which you will suspend your body under the 3 strings. The second one is a compound pendulum method. You will hang your object in between two rods and you will oscillate it. The third one was rolling on an inclined plane. You will release the object and it will roll. And the fourth one was the flex pivot method. It is actually like a cantilever beam. Those who know about cantilever. So we will give a little deflection and it will start oscillating. So one thing in common is this, that we will give an initial deflection and they will start oscillating. Then we organize all of this and note down these 4 parameters. The 4 parameters were accuracy, design complexity, safety, and approx costing. Because now we have conceptualized many designs. Now we have to select for some particular design. Then we considered all 4 parameters and we give a weightage to every part. While giving weightage, because our first target was to get a very accurate machines. So the most weighted part was accuracy. Then because we are handling various defense and space programs, it should be a very safe system. Then the third thing was costing. And the least prioritized was design complexity. Or you can say it is majorly because of that overconfidence in time to we can build anything. We can simplify a complex design to anything and we can solve a very complex design. And to give a weightage, there's one more method which I also explored. It was again from a textbook part, pug matrix method. Those who have done a course on product development, they must be knowing this pug matrix, in which you keep everything in a weighted manner and then choose which concept you want to go on and which is accurate as per your targets. Then after considering all these, we finalized one concept. That was flex pivot method. Why? Again, the first thing was the other method, like the hanging to the rods. There was a bearing. Bearing will cause a friction, and friction might cause an unvariable time period. If we hang it with the strings, there will be string elongations, and it is very less chance that it will oscillate in one plane. And if we go to the air bearings instead of these normal bearings, then it will go very high cost. And safety is also a concern. You cannot hang a missile or a rocket through these strings. But after considering all these parameters, we went to a mechanism with which we can measure the inertia, and it was flex pivot method. There was no bearing, there was no any moving part. You have to just give a oscillation like a cantilever, and it will start working. Then after all this, we came to the preliminary design. We made a 3D CAD. That is the first step of the converting our design to a very CAD design. Although it took a very long time to refine, to do, but as like I told, I'm very weak in documenting the things, so I was not doing anything in between. I just posted the final when I finished it, the 3D CAD modeling. Also, it was a preliminary design, but the machine looks like this. We can put our object in between these, in between two roller rings, and there are two flex pivots at the ends. And this part on which these roller rings are mounted, this will start oscillating as we give a oscillation with this roller arm. And when it will oscillate, we will put a sensor over some place to measure the time period. And by this time period, we can calculate the inertia. So that is how we approached, and the direction of rotation will be this longitudinal direction. It will oscillate about this direction, and then we can calculate the inertia values. Then again, 3D CAD model is done. Now we have to do some engineering calculations to actually think how accurate we can make our design, how good it will be. So just to give an overview of how does this design worked. So when you put an object and measure time period, our machine will give you inertia. So that inertia will be sum of that object plus on which that object is mounted, like the tail. So then in that calculation, we have to separate it out, the tail inertia and the object inertia. And of course, we will need a CG coordinates. Like most of you have studied mechanics, and there's a parallel axis theorem. In that parallel axis theorem, there is something, if the CG is offset, then you can calculate that inertia at any axis with those CG coordinates. And those CG coordinates will be obtained from our CG machine, and then we will use in these calculations. How to calculate the stiffness of the machine? Again, we will not calculate the stiffness by CAD only. We will not by CAD the stiffness. What we will do, we will put an object with a non-inertia, and then we will calculate the stiffness. By putting the non-inertia, we know the time periods, and in that three parameter equation, you can calculate the stiffness of a structure. Then after considering all those equations, we actually got a formula. And since this project is a very confidential project, I could not write a equation for it. But still, it came out a function of like 8 or 10 parameters, the CG coordinates or the deflections or many parameters. And it was a very long inertia formula. And with that formula, we calculate the error estimation. We all studied that in a course on semesters, numerical analysis. There are various ways of calculating the error sensitivity, and there are some good error estimation manuals also of NASA and Space Electronics. There is some good organization. So you can take those help and then start this error estimation, and then you can calculate which part is the most sensitive part on which you have to more focus, and which is the less sensitive part, I mean, whose accuracy will not matter you as much. So this error estimation gives us an idea which will focus more on accuracy and which part we can leave for the future. So then it was something of mechanical side. Then we came to how this data will be acquired. So what sensors we will need is this time period sensor to measure the time period. The second sensor was, since the machine will deflect when put the object, to measure the deflection, something laser sensor or something to measure the distance. And the third sensor was this inclinometer. Inclinometer is just to calculate the leveling, is if your machine is leveled or at an inclined plane, or you can know using the tilt sensor, placing a tilt sensor over it. Then to read this all sensors data, we need a data acquisition system from National Instruments. We bought a data acquisition system, and we need a software because we were planning to give a full customized software and full final. So these sensors will acquire data, process it in the software, and the final inertia values will be displayed on the display. You don't have to calculate or do anything. You just have to click one or two buttons. That's it. This was our target. We decided later on what all modifications can be made. And based on our previous error estimation data, we found that this accuracy was very less sensitive or was not depending much on that deflection part, because the deflection was so small. And even if you want to include the deflection part, we can do it manually also by putting some scale 3 or 4 mm. So we avoided to put a deflection measurement sensor over the device based on our calculations and estimation, and that's how we progressed onto our next phase. In the preliminary design only, when you are putting everything, you will make a preliminary BOM, which will include sensors like whatever all sensors you are using. You will use what manufacturing, what will things will be manufactured, electrical side, how that voltage will be converted, which PCB, which ADC, and how to develop the software, some testing services, what all instruments you will need for testing, and some accessories. You will need a PC to work on, enclosure in which all the electrical items will be put in. So these all things were put it again, documented on some place, and a preliminary BOM was made. Now next comes the simulation part. The most exciting part, we all are excited. Like Yogesh has already mentioned about it, how this when this all was over, this was my first project, and when I came here to this stage, now I will start simulating. And I was like, "Ab maza aayega na video." So we started this simulation part, and we designed like the first thing just before we start simulation was to define our target requirements, and that is what more important, because what we want to see from our simulations, what we want to check from our simulations. So we did 3 types of simulation in it. The first was one FE simulations to check the strength and the rigidity of our machine. The second simulation was multiple dynamics to check that there are 2 flex pivots. 2 flex pivots are a little offset or some direction. What will the effect of that on time period on the accuracy of machine? Because when you will go for manufacturing and it's a very long machine, 5 to 10 meters long, at accuracy of 1 mm or 2 mm with that accurate, it will be very difficult. So we wanted to see how much tolerance we can put in putting that line of flex pivots. So we studied that into simulations, and we wanted to know what will be the frequency or time period, approx time period, so that we can select a sensor with that frequency range. And then there was a software part. We wanted to test the main logic of the software, and we wanted to reduce the bugs in the software. So these 3 softwares we used to simulating just before our physical simulation was started. So I will go through an overview of the simulations. I will not go through the details of simulations. And I have avoided putting numbers just again to maintain the confidentiality. And I will just go through what all inputs we put, what all outputs we wanted to know, what all assumptions were there. And so in FE simulations, we did 2 cases. The first one was a pull case, in which you are putting an object and its CG is just at the center of your machine. And its second case, the body CG is offset from the center of the machine. We give some forces, what you all expected a human man can put onto a rig, and we decided how much deflection we want to give, or oscillation angle we want to give out to a machine. We put that inputs into a machine, into a simulated design. We selected some materials, and we selected based on the costing part also came into it. Like we cannot make a whole machine to be stainless steel just at the main heart of the system, which is a flex pivot. We went for stainless steel, and at the structure part, we went for mild steel. Then we did we Next step for calculating FE was for assumptions. So what assumptions we put was actually to simplify our design. We don't need to actually do a very complex things, because in this case we were hopeful to give a very good factor of safety to our rigs. So that is why we give a homogeneous and isotropic conditions, and we considered that weld and bolts are stronger, and this fasteners, sensors, electric wires, they're not considered as of now into a machine. It is just a 3D CAD model with all the mechanical parts. So this was our 3D CAD model. This is how we exported into FE. This is having 8 reaction points. It is mounted on the ground, so it is having 8 reaction points. We are putting some mass over it, and we are giving a translating force from this direction, and then it will be simulated to know the forces and rigidity. So this was the first case. We wanted to measure the rigidity, a deflection of our system. So after designing it, when we put the load at the center, we found that the maximum deflection is at the center, and that was obvious as well. Just like simply supported beam, when you put an object, it will deflect and will deflect at the maximum only. And we came to know with this some delta deflection. Actually, this was shown again for confidentiality. I removed this part to so delta deflection. We now know the deflection, how much deflection our body can be, our machine can be, and that can be improved in the design, reiterated design, then again simulated, so that we can get our machine within that vertical displacement range. The second output was the stress, which is the main component. Will be having the maximum stress in our machine, and with that we found that flex pivot was having the maximum stress. Again, just like the theoretical concept, we were very sure they will be a simply supported beam and the maximum reaction is at the ends. So again, the maximum stress, we found the maximum stress, and we checked all these parameters with what material we have selected. Suppose some stress at the maximum stress at this ends is coming like 100, and we have considered stainless steel is having a stress of 500 or 600 megapascal, then our design is very safe. We don't need to redesign it or reiterate the design. And the second simulation in FE was to put an offset. Like we are not putting the body in the center, we put it with an offset of like 550 or 60 mm, or keep varying it over the length. And we found that it is varying, but the deflection which was measured was almost the same, which was in the previous case with the center loading. And that helped us to think of irrespective of the place where we put our object, the deflection will be almost the same, or we know the maximum deflection. And if that matches our range, then we can move forward with design. And if it doesn't matches our range, then we have to go back and redesign it and then again simulate it. Again, that is stress. In the offset case, it was coming maximum at the ends, and this was again matched with the stress levels of that material which we have selected, and that compared with what will be the factor of safety into it, and then we decided whether we want to move this design forward or want to go and back again. So that was the FE parts. The second part in the simulation was this MBD part, multi-body dynamics. And this again, it is very important to simplify design into a very simple design. What can we make into this? We can make this whole body into a flexible body, and we can put many joints, many forces over it. But just to simplify this design, we considered only this flex pivots as a flexible body, and considered this this stair as a rigid body, because our main objective in this simulation was not to calculate the deflection, not to calculate the rigidity, but was if we give an offset, how will be the time period vary? How will this time period accuracy will be affected if there's an offset? So with that objective, we design our simulation, we put inputs, we define the outputs, we give a damping ratio, and we defined all the bodies, joints, everything. And then we came to results. So two results were plotted in this simulations. First one was the angle, the deflection angle, the oscillation angle versus time, and another one was the amplitude versus time, with different damping ratios, with different offsets, and with that simulations, we come to know like there is an error with some data over this graphs. There is some offset error which can be generated when we go to manufacturing. So that error has also to be considered in that error estimation part. So when we initially started estimating our error, so then we went back again and put this offset error into that, then again reiterated and calculated the total error estimation. And the third simulation was LabVIEW simulation. So in LabVIEW, as you all might be knowing this, can simulate a USB device or a chassis or deck device into the software, and you can generate a signal, whatever signal you want to, and then you can test your code with that artificial signals. And with that part, we started testing our simulation codes, defining, refining, and then we finalized our main code. We are not going through the whole architecture. And this is stage we went through that initial code. Now here comes the detailed design part. So in detailed designing, since you all know that this project was having this mechanical part, the electrical part, some sensors, and of course software. And just to give an overview of our team of this project, it was a 6 members team and all were mechanical engineers. So the first question when we preliminary design is okay, we all are very basic things, we all can do that. Now here comes who will do the electrical and the software detailing. And this is my reaction. I will do. Whenever anything was there, I will do. मेरे को सब आता है. Even though I never knew, I never did it. But because at that time there was a lockdown, I started learning those things from some courses, edX or Coursera. And then I took this responsibility to do the electrical and the software side detailing part. And I initially little bit of backed out from mechanical part and went into the electrical and software detailing. Although I was attached to mechanical part as well, but this experience of switching with mechanical, with electrical, with software, and generating a full product from starting up to till the software. That was I was going through with the flow, whatever it was there. Then we made a final CAD design. That consisted of, again, what we have already discussed. It consisted of some U blocks which will hold that assembly. It consists of some flex pivots which will help us to oscillate. It consists of some level screw which will help us to leveling with the ground if it is inclined or if it is a unparalleled ground. And also, as you can see, this magenta color is that rotating part, and then this green color is that fixed part. So this fixed part, we call it as base, and this magenta color part, we call it as tail, the oscillating part. Then in 3D CAD modeling only final, we wanted to measure the time period also. So we wanted to put a sensor, time period measurement sensor. We call it as photogate sensor. So that was put it on the base, and from the tail there was a rod on which the arm was mounted, and it was oscillating, just blocking through the photogate sensor. So as the time it was blocking the photogate sensor, it was measuring the time of half time period, and that was used as to calculate the inertia of our object. In our electrical enclosure, because all of our data agreement system, the safety part, filtering of the power converters, and some PCBs or some analog to digital converters, and some digital analog converters and a power supply. So we all put that into the 3D CAD model. And this electrical part also, like I was designing that architecture, someone was modeling in the 3D software. And this was how our enclosure was looking at. This enclosure looked at like this. It was having some indicators, some push buttons, some switches, some safety system, some handle. And the most important thing I would mention, there was a fan in this, and that was the only thermal thing I did in this project. Although I did my MTech in thermal, I was doing everything, electrical, mechanical, and all, but this was the only thing which was related to my branch, the designing how much heat will be generated in that design and how much capacity fan we will be putting into this exhaust fan. Then we put into the software part, detailed designing. So overview of this architecture was already designed in a preliminary design, but then the back, the background of this software, the back panel, I was doing all this software part through the codes, through the overall architecture to remove all the bugs so that software can run smoothly, to make a exe file. So I did all this detailing part and made a software which looked like this. The front screen looked like this. And this software was actually for all our three machines, CG machine, inertia machines, and mass measurement machines. And in that front screen also, its IXX measurement looked like this. We will be having 3 iterations. We can put our values of deflection and the time periods. And with that time period, you just have to press the next, and then you can calculate the exactly what inertia value will be. Then after designing this overall CAD structure, then one of the most important part after we designed the CAD structure was the design review. In design review, it was actually in between also in previous iteration also, but a major design review was conducted with firstly some internal members outside our project team so that they can give their feedbacks to our design. And then the design was presented to the customer also, like this is how we are planning to, this is how we will measure, this is how the accuracy will be, this is how the software GUI will work, and this is how you can plug it somewhere, and you just have to get this. This was presented to the customer also, and based on the feedback, then some modifications and improvements were made. There were some minor modifications. We made that, and we finalized. So after we design review was conducted, we got the approval from our internal meeting and the customer. Then the next part was to go more detailing into the design. We started detailing into the CAD, into 2D for manufacturing with some dimensional tolerances. Then some components with proper GD&T, how much tolerances we have to give, which manufacturing process we will use. These all were defined into this structure. And software development part also, the back panel, the back end part of the software was also finalized. Some modifications on the GUI part was there, so they were also modified, and we made this software, and that was really good experience for me.
Okay, I think Shashank is having some network issues. Wait for him to join back. But
Can I ask a question?
Yeah, sure. Go ahead.
Yeah. So my question is, who can perform better in a industry?
Can you please introduce yourself, please?
Sorry, sir. I'm Abhishek, and I'm from NIT Allahabad. So my question is, who can perform better in an industry, especially mechanical domain, a generalist or a specialist?
I think there is place for both in the industry. I mean, even at Time Tooth, we have both kinds of people who are experts in simulations. They will do every kind of simulation, even like the most complex things. And then there are people like me or Shashank who kind of work more on the systems side. Uh, what I would say is the way the industry is shaping up, and with uh, even in mechanical or with the advent of embedded and IoT technologies, I think even if you don't acquire the skill sets, it is really good to have that mindset, because even if you are a specialist, you will have to interact with other teams, other domains, uh, other people that are working. Let's say if you are a structural analyst, and you will have to maybe interact with the multi-body dynamics team member or with the CFD team member. So I mean, having that mindset, I think, is just really important. Okay, so Shashank is back.
Sorry, there was a power connection
Thank you,
loss. Yeah. Am I audible?
Yes, yes.
Yeah, okay. So yeah, after that we to the all previous part, we started detailing the electrical circuits also. This was again done by me only. What all I learned during like 7-8 years back into electrical engineering. And actually this was not that difficult because these are the basic things like MCB, LCCB, or some power supply, which we are all using in our basic life as well. So this was not that difficult, but yeah, that was a great understanding for me also. Then, yeah, during this, while all this was happening, this was my first project after my college. So I asked this question to me, why? Why you have done your master's in thermal engineering? What is the thing? What is the thing you are doing? This is product development, and you are not doing anything related to thermal. But actually, I told myself, this question can be interpreted like this, like in which line I am. But then my heart said, I was already started enjoying what all was I doing. I started learning those courses. I started doing those courses. I started designing electrical circuit, designing software architecture, and with that flow, I went, and I did not realize in between through this whole project summary, like I did my MTech in something else. This was not my area, but that was really a great experience for me. Then I continued, like I will, till this phase I did everything. So I will go ahead and finish this. So the next step was this vendor identification. So once you have finalized all your components, all your sensors, all your data ecosystem, all electrical parts, all CAD is done, then you will start identifying the vendors for it. The important parameters, what will be considered for shortlisting and identification of various vendors are, the first thing is product specifications. What product you want, with what frequency, with what accuracy, what voltage level, and what certifications you need in that, and what is the cost of that product, what is the lead time, whether it will be imported or some we have to export it from import it from somewhere else. Then a sheet like this is made, which consists of component, which model we want to procure, what are the vendors for it, contact persons, and this all things was done to help and assist us to procure something very easily with considering all those parameters. Then on the next phase was to prepare an inspection report. An inspection report, I'm just sharing just only for a normal plate. We're having 3 holes into it. And similar to this, every component, every specified small parts, because we are giving this outside for manufacturing, what will be the upper limits, what will be the lower limits, how we will confirm like what he has manufactured is correct or not, that process. So this is a general view of how this inspection reports looks like. And then we prepared a final BOM just before releasing it for manufacturing. Like these are the members we require. There were lists of like 300-400 components, and then 300-400 components will be assembled together, small four components, and then we will make a big machine to it. Then the next part was to schedule a test. Since we have finalized vendors, we have designed detailed for manufacturing. We have finalized the vendors. Now the next phase we did was to plan how we test our system, how we test our machines, what will be the requirements, what will be the tools, what will be the acceptance criteria that up to above this level will not accept, what will be the procedure, and based on that we prepared a tables with some inputs, outputs, expected results, or whatever things we are comparing at. So we prepared this whole procedures and all. Then we came to prototype and manufacturing. Then we ordered all those parts, electrical parts, sensors and actuators. This machine was manufactured at some facility. These are all the images of that manufacturing process going on. These are the rigs. This rig was having actually 3 major parts, and that it was assembled together. This was our calibration body, and this was our enclosure design. So we did all this. The manufacturing was done, and then so after this manufacturing was done, we again, like, initially we prepared an inspection report, then we compared those, we put the actual dimensions, like the drawing dimensions was 180 and the measure dimensions was 180 180.1, but what we designed was, if it is plus minus 0.5, then it is accepted. So with that consideration, we measure all those dimensions at some manufacturer's facility with those instruments, with this inspection report, and give our remarks whether they can accept or not. Then the next phase was integration and testing. So this was integration at our facility, at our lab only. So this was a set of tools, what all, how did we assembled, or how did we put U blocks and all. If some modifications were required, we found that, okay, this we can reduce it little, then we grinded it a little. Some modifications were made during integration also. But we then we finally made a full test machine, which looked like this. This is a IXX roll inertia measuring machine. And our other part looked like this, which had a PC, data acquisition management system, and a printer. So this, after this full integration, it was like you just have to plug the cables, so open the software, take the readings, and you will get the inertia values. You don't have to do anything, and you can print out the reports. So we've made this all inertia calculations is as simple, like within few minutes you can get the full report of the inertia, the mass, that's everything. Then with this, we also decided to test the software with that actual machine. Till now, we were testing it with that simulated part in LabVIEW. So we decided to test the software, to test this part with that machine, and we got this testing results. So I have hidden these parameters again for the confidentiality purpose, but I will try to mention that the error, full scale error was coming 3.56%, 2.5%, and more than 7%. And what we were expecting it was below 4%. So we did everything. We did design detailing, GD&T, inspection, calculations, error estimation. But by the time of testing, this happened. And this was my boss reaction. After we did everything, so welcome to the product development. It is not as simple as you are designing, as you're planning on the text, on the notebooks, as you're documenting. It doesn't work like that. So something I started feeling this, like it is not that easy. Something happened. I was following just the solutions, that documented things, but then the next stage after that swad aa gaya, was design refinement. So in design refinement, we actually went what can be the reasons of that error. In software, we noticed that there is a fluctuating time period. So when you see the curves of a time period with the damping, the amplitude decreases, but the time periods remains the constant. And when we are recording that, the time period was not coming constant. It was fluctuating a little. Then we went back, started what all problems can be there. The sensors might not be working, data acquisition, our device, the National Instrument DAC system might not be working, or there is some error in the software side, we are not able to acquire data properly, or some problem. Although we inspected everything, but is there something which we did not inspect it properly, or which is affecting this error estimation? So after this, we found that that rod which was crossing our photo gate sensor, was touching when we were putting the object. It was touching the base of the sensor, and there was some friction over it. And we did not. It was actually oscillating, but there was a slight friction. The rod was touching because of the deflection of the machine. Then what we did, instead of putting this vertical rod at the fix, we put it as flexible with some screw. We uh, we were able to adjust it manually so that there is always a gap between the sensor and that rod so that it can oscillate properly. That modification was made. That was manufactured again. That redesigned, and after that, finally, we got that error within 4% what we were targeting. I've only just mentioned 4-5 iterations. We did actually like 40-50 iterations, and every time we got our error as per our requirements. So finally, this all was done. It was a great feeling because when that error was coming, it was difficult. It was very difficult to even get a proper sleep. It is very difficult because you have worked for that project for a whole year. You have done everything correct, and then you're not getting that error. You're not getting that accuracy, what you were supposed to do. And accuracy was the topmost priority of our project. Then we got these results. It was a very good time for all of us, for our team. And then final inspection, we disassembled that machine into some parts and packed it into some boxes, sensors, all some different boxes, loaded it into a truck, and we finally dispatched this machine into a customer company. And after delivering this, there was one more part which was left, and that was again the most hectic part of all this for me, preparation of manuals. Of course, we took some help from some outside member also in that, because it was very difficult for me to prepare 200 and 200 pages manuals. So I prepared a structure of a manual, user manual, training manual, and the maintenance manuals. These are manuals are there which you have to give it to the customer. So our operational maintenance level manual page looked like this on the first page. And these are the contents what we included in our manual: the introduction, the technical specifications, the installation instructions, the installation of machines, as well as the acquisition system, as well as the software, the operations part, how to diagnose the sensor, how to calibrate the sensor, how to measure the readings with sensor from the machine to the software part, how to maintain those machines over a long period of time, and those calibration parts. So these are the all contents on that which you consider in the manual. Then we went into the client's space, we assembled it there with that assembly procedure mentioned in that manuals. Then we tested at their facility with a live object, and that was again a very uh, I was getting a little anxiety or something. My heartbeat was high because you are putting a live object into it, and that live object will, as well, a defense project that will be used at a national importance, and they will be relying to control that object with our parameters. So it was a great, actually. We put that object onto a machine. We give that they tested and showed that the results are accurate. And again, we first initially tested there with our calibration body, then with the object. We gave them the coordinates, and we finally finished this project with installation at their place. Everything was working properly till the time we left. We give them the training for calibration, how to use, how to calibrate it, operations and maintenance by the manual with that hardware part. So this was our CGMOI Center of Gravity and Moment of Inertia team. A very thankful to my team actually. We all from mechanical engineers doing a project in the interdisciplinary thing, all helping together. After this project, I did not mention this, we had 2 trips also after completing this, because this project took 1 year and loads of ups and downs, COVID lockdown, and the manufacturer is not able to dispatch on time. We have to dispatch the product on time, lots of errors, sources. And we as a team resolved everything. If I was not able to do, someone else was able to do. If he was not able to do, someone else was able to do. But we mentioned every error, every uncertainty was corrected, and it was meeting the standards, the accuracy levels. And this team, after this project, we as a team, like these 2 teams are like, we have 2 offices in Noida as in Bangalore. We became good friends. I was not having much contact with the Noida team, but after till the time of completion this project, we became good friends. We started going to outside for dinners, for trips, and that's how it all went. And we finished this project, interdisciplinary project, where I learned everything from starting from the scratch, ideation to the installation and testing of a live object. So yeah, thank you for being a kind listeners. This was my experience, my personal experience.
Yeah, wait, Shashank, you are not going anywhere. The students are not going to leave you because we are opening it for the questions.
Yeah,
Yeah,
sure,
yeah.
Dr. Dheeraj,
Yeah,
we are
okay.
not leaving right
Yeah.
now, but thanks a lot, Shashank, and
Yeah.
definitely good use of memes. जैसे बस्सी बोलता है, अब्दुल ज्यादा फेमस हो रहा है.
अभी बस्सी के गांव से है तो थोड़ा तो बनता है.
Uh, so,
So
but yeah, really good. I mean,
wonderfully done, Yogesh and Shashank. I think student really enjoyed it. So should I open it for
नहीं,
question answer?
Dr. Dheeraj, just some closing remarks. Uh, can you make me the presenter, please?
Dharmender, can you do that?
Okay,
Please?
yes, sir, yes, sir, yes, sir. Yes, sir. Yes.
So yeah, there are some things that Shashank touched on in the end, but yeah, at time too, we have been lucky that all of our team is not hesitant. Yeah, they don't say that, I'm a thermal engineer, I'm a structural engineer, I will not do something, and uh, and we are just really committed to making that product successful. And uh, and I think that is something I would encourage you to take into your life, that you have to first focus on that why and making that product successful, and that is the only way to succeed. uh, Other than that, I think during this presentation during Sashank's presentation, I could also see his passion for what he did. I mean, he told me that he'll take 40 minutes to complete this, but I think it's already almost an hour. So once he got started, and just going into those details, and uh, thanks, Shashank, for kind of making me realize that. But other than that, we touched on the basic concepts, but we have tried to keep it tool agnostic, and and kind of an industry agnostic. We had more perspectives from our mechanical engineering experience, but you can basically apply this to any industry, any domain, and you can use any tool for specific things, like how do we get the requirements? Use Google. I mean, that is what you have to do. Now I think you're all really good at using Google, so do that. So there is one more thing I wanted to mention about the movement of inertia machines. Uh, so even with the COVID lockdowns, even with all the challenges that we faced with the error, uh, going more than 4% स्वाद आने के बाद भी we were able to deliver it on time and within our budget. So, so other than just the core engineering, there is a lot that goes into making a product, making a project successful and delivering a product. But so which is basically a project management side of it, the planning and tracking, which we have not gone into the detail because I think Mr. Tambi has already covered that beautifully. There is another part that Shashank mentioned, and we feel is really working with a great team. Uh, we hope that the next session on building teams is something you will enjoy and take back to your life. Uh, but uh, but the other thing that I wanted to mention is that product development is a very evolving process. Time Tooth has also come to this stage after, let's say, 10 years. So this has been our attempt to, kind of summarize that. But these things are changing, and design thinking is something that I am personally very interested in, and I I would suggest that you look into that approach of design thinking and product development. Uh, just to close, I mean, we are probably optimistic people, but wherever we go, HAL, maybe Navy yards or Air Force or Army campuses, we see a huge potential of indigenization. There are so many products from a basic system to a very complex system that you can develop in India, and that is what brings joy to us. And just to just be aware that there is a huge potential of just using your basic engineering concepts and developing products. So just all the best to all of you. We hope we did okay. uh, and thanks a lot, Dr. Dheeraj, for inviting us. I mean, I just enjoyed reminiscing those old memories.
Yeah. I'm really happy that you both came as a twin brothers to explain the whole gamut of product development. But before I open the stage for asking question to student, uh, my personal, since I am a head training and placement cell IIT Robert, I know there is always something going on because Indian core engineering, and I'm sure everywhere the core engineering jobs are less paid. But I think, to me, the fun of engineering is of course in the beginning, 2 3 years, 4 years. I think money should not be the driving parameter towards getting into a job. So because learning these things, it's once you go into a software domain and all, you are one brick in the big cluster where people are doing things. But when you are into product development in a core sector job, the fun is really different. So which you already explained. So what is your take on that? Because this is the question that every student is facing these days in India, that core job pay them less, but software job pay them more, even though they have to learn extra, like what they have studied in the subject, they have to do extra classes or something more. But what is your take on that?
I mean, I can definitely explain my take, but I am also aware of the other caveat. If someone came to me during my college time when I was in third year and said to me, "हाँ, code अच्छा है, do this. I mean, this is where you will enjoy more." I would probably not have agreed or even listened to what they were saying. But this is something that with time I have realized is basically, I mean, not a question of core versus non-core or anything else, but more than money, it is what is inside you and what drives you that matters. What is your passion? So find that. I would not say ki you have done your engineering in mechanical, so stay in mechanical, or you are a civil engineer, so stay in civil. But actually work on finding where you are passionate about. Money is something that will follow. There is no doubt about that. Uh,
Mhm.
so there are a lot of lots of things that I keep on reading, but which say basically is that your 20s are to basically explore yourself. I mean, so basically develop that exploratory mindset. Try things out. Don't be afraid to fail. And in terms of opportunity, I mean, even in core, there are lots of opportunities. Maybe it will be a little more difficult than, let's say, a software job or a data analytics job, but but basically you have to strive for it. And like I said, there is no limit to the potential of engineering products in India.
Yeah. Yeah. Thank you. Thank you, Yogesh. Thank you, Shashank. So with this, I am opening the stage for questions. So if you can see, people are raising their hands in that participant list. So
Yeah, just
I will be asking them to unmute themselves layer by layer, line by line, in the sequence, and they will be asking questions to you. So, guys, I have another meeting at 2. Probably I will leave. Shashank and Yogesh, if you want to stay after 2, you are free to stay. Okay. The kids have a lot of questions to ask, so they will be keeping you busy. So I wish we can send you pizza there at your home. So, but it's not possible.
yeah, sure. That's what I was saying, that that we are always happy, chat up. I don't know if Shashank had his breakfast yet or not, though.
Okay. So I think Ashirvad, you can start with your question. So
Yeah. Good afternoon, sir. I am Asirvad Sahu from CET Bhubaneswar, Odisha. Sir, my question is that before going for a product development phase, what knowledge and skills we should acquire as a mechanical engineer?
शशांक, तुम आंसर करो यार, ये वाला अभी एक साल ही हुआ है. क्या knowledge was required for you to develop a product?
To develop a product, so the main important thing, concept. So what you can learn in college, you will not be able to learn that management side. If you're participating in some fests, you're participating in some clubs, then you might already be knowing how to manage that funds. So you can join those clubs, manage those things. From there, you can manage some skills in management, the costing part. The second part is skills. And skills, most importantly, what I realize is it's not the simulation part to, like Yogesh already mentioned, uh, to generate the concept. That is what more important, to understand what is going around and to make a notes, like Yogesh already mentioned. On the right hand side, you know what, how can you use it, where you can use it. That part can be done with your studies, and with that you can make your mentality to make a product.
Thank you, sir. Sir, we should focus more on the experimental, the project part, or we should focus more on the theoretical part that has been taught in college?
See, few things like project management, these things are little bit, I realize they are most more towards that experience side. I learned these things with working. Okay, I have three sensors. One is of 15,000, 20,000, 5,000. But I know this 5,000 one is Chinese. So that decision I have to take, how to manage it, and have to cost cut somewhere else. So these things I learned with experience only. But concept developing and this can be done with parallel with the studies only.
So yeah, I would say the same. I mean, basically focus on your fundamentals first. That is the most important. Now, I think with our session, you have a blueprint of what goes into a product development. So maybe research more on the individual aspects of it. But on the other hand, I would definitely recommend that you actually develop something physical out of it, because the experience or the perspective that provides is not something you will just have sitting on your computer or just reading your books. So yeah, I think focus on these three things.
Thank you, sir. Thank you.
I think there's Anmol. Can ask your question.
Hello, sir. I'm Anmol this side from CCT Chandigarh.
Hi, Anmol.
Sir, first of all, thank you for delivering such a beautiful session. And I'm having very general question that if a mechanical engineer have to do the work of electronic engineer and computer engineer, how to overcome that fear working perfectly in that?
So So tell me, where does that fear come from? What are you most afraid of when?
Like I'm making one robo race car. In this, I have made the car, fit the motors and all. But when the time came to Arduino programming, I'm talking about in second year when I went. So I am very fear of that. That what is it Arduino programming? How will I do it? Then I have to consult with my electronic friend to do that. So
Right.
this is one of the example, and many challenges come like that. So how you face that fear?
So there are two things to it. So one is I would commend you for actually taking that step of talking to a friend. That was the first thing I was going to recommend. That so basically understand the fundamentals of let's say electronics or computers. There are right now so many courses. I mean, even today we are getting into some more embedded, so detailed embedded stuff. I have found a course on Coursera that hardly takes 3 hours to get through the basics. So, I mean, just probably do something like that. Do a small course or talk to a friend. Tell him कि यार तुझे ये अच्छा आता है. Explain to me what are the basics of it. And
Okay.
then the second part of it is, I think, actually doing that. So what is generally called in psychology as a confidence competence loop. So so if you are confident in something, you will work on it, you will build your competence. That competence will give you confidence, and then basically that builds on. So kind of just to have that basic knowledge and then try it out. As you keep building on it, you will feel more confident.
Right, sir. Right. Thank you. Okay.
We have Abhishek.
Yes. Hello, sir. I am from Abhishek from NIT Allahabad. My question to you is, sir, I want to know in a project while developing a product, how you distribute work, that what someone has to do, what other things has to do.
Yeah, so good. So nowadays, when we first start a project discussion, we first ask ourselves these questions: What are my interests? What is something that I want to grow in? And what are my skills or my competencies? So basically, dividing your roles, your responsibilities based on these three parameters. What are your core competencies? What are you interested in? And what do you want to grow yourself in? And I think it was you that asked another question that was basically related to mechanical, electronics, and software people working together. Uh, so I would just address that question is basically so when you have to work in a multidisciplinary team. So one is it is important to have that mindset like I talked about earlier. So you don't have to know the skills of software development, but you should have an idea of what goes into a software development. So you can probably once you form your teams, you can talk amongst yourself. You can probably give half an hour basic understanding of your core competencies to the other team members. Then the other part of it comes down to basically identifying those interfaces. When is your mechanical component going to interface with electronics? What are those interface requirements? So first is define those requirements. Like I mentioned earlier, so system to subsystem to components. So just keep doing that until you have requirements for each of your subsystem very well defined. And then basically each team member has to take account of when should we communicate. So whenever there is a design change that would, so let's say I'm designing the electronics aspect of it. Maybe my PCB is going too big, which will affect my overall mechanical design. So if there are changes like that, we should communicate. So basically those interface is where you need to focus the most on.
Thank you very much, sir.
Hi, Gaurav. What is the question that you have? Okay.
Good afternoon, sir.
Akash.
Good afternoon, sir. Gaurav this side from NIT Allahabad.
Hi, Gaurav.
Sir, what advice do you give to the aspiring mechanical engineers so that we can be future ready? because as the job market and other skills market is currently changing, we tend to waste our time on getting involved in many skills. But what are the primary things we must do, like that are necessary in future for when we are developing on real projects?
So, okay, ask me this way. We covered a lot of things in the presentation. What matched or what else do you want to know uh, that you feel is missing?
No, sir. Like as Shashank sir said that he was from thermal engineering background and he was worked upon electrical domain. So like as we know that in future mechatronics will be ruling the this mechanical department. So as but we do not get an opportunity in the colleges to explore all these domains. So how should we take this action? And now due to online,
Again,
we are not able or to do the practical projects, like our projects are in the clubs also. So how should we maintain the quality of skills in this time?
so I think being online also opens access to, like I said, Coursera or edX or some other courses that you can explore. Definitely is one thing. You can form virtual working groups that, you know, so what you do in college, maybe take a small part of it, form a team, do something in your free time. Then if you actually have to, let's say, get into embedded or that electronic side, buy a small Arduino kit, start playing around with it, and actually take some ambitious project. So after you're done with your basic tutorials and stuff, so think of something, maybe solving something at your home or some problem that you're facing, try to solve that, develop that uh, problem solving mindset is what I would recommend. Shashank, you have anything to add?
Yeah, just to add this, like online systems, we don't have the facility to test and learn practically. So, like 3, 4 months back, I don't know if it's still there or not. There was a course on edX, so it was a free course only. With that, there was a very cheap toolkit and some instruments they were telling you can buy these things. And for the whole lectures, it was a 3 months course. You can buy those things and test and make your own quadcopter. Like this, there are already many projects. You can learn that. You can buy when it's a very cheap things, Arduino boards and these cables. You can build your own also. There's no such thing that you have to be in your lab only. You can make something robots for your own.
So thank you, sir.
Yep, and also saying that it is not necessary to, learn those electronics or those software. I mean, if you are basically interested in mechanical, you can still explore more on that. Like I said, even at Time Tooth, not everybody is like me or Shashank who works on these multidisciplinary projects. There are people who are core mechanical specialists. So, I mean, it is basically again on to what is it that your heart desires. Uh, Okay, Ekansh,
Yes, sir. My name is Ekansh Mishra and I'm from VIT Mesra Ranchi. Sir, my question is, like in college, when we build some project, the project is already fixed. Like in Baha, we have to make a car. But when we get in solving real world problems and we see what are the requirements, then from there, how do we like decide that uh, like from the basic requirements and need, how do we decide what to design and where to go?
so give me an example. Uh, I think especially in these cases, generic questions I mean, I could give you some funda, but that will not ultimately be useful to you. So if you have some specific examples, then I can probably, explain to you how to proceed in that.
Sir, uh, in this internship, there are different projects like for fisheries and then many others. So like, how do we select what to design from there?
Okay, so yeah, actually that got me to a very good point. So now you have heard, from from people who are basically, let's say, in the fisheries domain or in the agriculture domain or in the food processing domain. So so take those 10 projects and first thing to do is again start with why. Uh, so so think of the project that you are interested in and think why? Why should I work on this project? Why is this project important? So actually, everyone, let's take 2 minutes. I will be silent and just choose that project of interest that you want to work on out of those 10 and think of why. Also, you can note it down for your future reference. So, okay, you have probably thought about it now, or maybe you can keep thinking about this later. But once you have that why in place, simple. Go to your objectives, your scope of work, what will be your deliverables, and what are your requirements. Define those functional requirements. Bring it onto pen and paper. So let's say you, uh, one second, let me open that. So I guess the first project that I see is electrical vehicles and cobotics for agriculture, design of swarm robots for agriculture applications. So so first, again, define what is the objective. So I think you have an objective in place here, but expand on that. Describe what that system will do. Describe what will be your scope of work. Thinking of, let's say you have 6 months. So what all work will go into, let's say, designing such a system? What think of a basic concept. Think of what will be your deliverables, whether you will basically make a design out of it, whether you will test some part of it, whether you will deliver a prototype, whether you will do some demonstration, whether you will actually make, let's say, 10 products out of it. So think of those deliverables, think of those requirements. I mean, map it down. So what does the electric vehicle for agriculture mean? What will be its performance parameters? कि अभी इसको इतने घंटे काम करना है बैटरी पे, या फिर इसको ऐसे टेरेन में चलना है, उसके अंदर क्या क्या कंपोनेंट्स होने चाहिए, कि उसको अभी सीड डालना है वहाँ पे एग्रीकल्चर में जाके, या एग्जैक्टली काम क्या करना है उसको. सो स्टार्ट थिंकिंग अबाउट दोज थिंग्स एंड एंड कीप बिल्डिंग ऑन दैट, देन डेवलप कॉन्सेप्ट्स. So now that said, if if you have any specific problem that you would like to talk to us about, you can email us. We would be happy to volunteer and help you build your idea. Me and Shashank are there. We can also get some other time tooth team members involved. Uh, and yeah, I mean, we'll be excited to work on that too. Does that make sense?
Yes, sir. Thank you.
Okay, we have Sandeep.
Hi, sir. I'm Sandeep from HITS Chennai. Firstly, sir, it was an amazing session, and I kind of have a very generic question. Ki, like, how to be an ideal engineer? Because, sir, like, since my childhood, like, since my schooling, I never came up with a class about business development or else about setting up a startup. And वैसे भी ये engineering भी 4 साल वैसे लॉकडाउन में हो जाएगा. So my major question is, if I have an idea on a startup, and should I just stick on it, or else should I just not focusing completely on it, or just should I like at least focus something on my main core, so that because the startup field, it's not too sure that whether it would persist or not. So what would you tell on this, sir?
Yeah, definitely. I mean, doing a startup
I mean,
is very risky, for sure.
yeah,
So,
sir. I mean, like a lot of seniors and my friends will say, ये course कर ले तेरा set हो जाएगा, वो course कर ले, ये course कर ले. But so as an engineer, so what would you tell?
I would say follow your passion. क्या होगा अभी 2 साल बाद जॉब नहीं होगी, यही है ना रिस्क.
Yeah, sir.
पेरेंट्स नहीं मानेंगे.
Yeah, sir.
So, okay. अच्छा, उसके लिए भी actually there is a good exercise that you can probably do. So this funda basically comes from stoicism, uh, कि कि when you have to take major decisions in life, okay, so तो हम लोग सारे pros cons list या वो सब तो बनाते हैं, but actually do something. अपनी आंखें बंद करो, actually imagine कि जो worst possible scenario है उस केस का. Let's say you did startup or you took a job. What is the worst possible thing you can think of कि वो हो सकता है, और वो बस सोचना नहीं है, actually imagine that that is happening to you. So is that something you can live with, is all I think that matters. So let's say you took a job that you were not interested in, you did 2 years into that, 5 years into that. Think of what is the worst case that happened to you. I mean, and think of, let's say, a startup. Your parents did not agree, your friends did not support you, you failed in your startup. But actually imagine what would that look like, and I think take a call. But other than that, I mean, I would encourage risk taking. Like I said, 20s are for exploration. The experience you gain or the exposure you get is, I feel, the most important part of it. Baki, keep developing your basic skills. Focus on those things. Definitely.
Okay, sir. Thank you, sir.
Okay, we have 2 Abhisheks now. The next 2 questions for Shashank. Okay, any more questions? Otherwise, we could close the session now. Shashank, का भी breakfast करना है.
Hello, sir.
Hello.
Sir, myself Abhishek Shahu, and I'm from Shri Ramdev College of Engineering and Management, Nagpur. Sir, actually, I'm the part of Aero Modeling Club in my college, and I want to ask you that sometimes we brainstorm on a particular means we make a RC planes at our home in a group in a teamwork only in a team, and sometimes we select a problem statement and brainstorm on it and divide the domains such as कि एरोफॉइल पे ये काम करेगा, इलेक्ट्रॉनिक्स ये संभालेगा, एंड फ्यूजलेज ये देख लेगा, लैंडिंग एरिया देख लेगा. तो समटाइम्स वी means divide the work between our team. Then we go for a flight to taste that RC plane, and what happens is that when we take a flight and means sometimes due to some problems the plane gets crashes. It may be the problem of the wind or as well as the defects in our RC plane. So we fixed it and again try to take a flight. What happens is that after doing so many attempts, means if I take two attempts, then then I got first stated that ये काम तेरा था तूने नहीं किया, ये काम इसकी वजह से ऐसा हो गया. So I am scolding on means friend कि तूने अगर ये अच्छे से किया होता तो आज फ्लाइट अच्छी होती है और अपने को means required parameters मिल जाते हैं. So this type of things happens when we are at field. So how to overcome that, sir? I want to means this is my question. How to overcome that situation?
कैसे करते हो भाई शशांक ये मैनेज?
I'm
तुम्हारा
giving
मैन्युफैक्चरर जब एक दूसरे पे ब्लेम डालता है, तुम्हारे टीम मेंबर्स जब ऐसा करते हैं, व्हाट डू यू डू?
Yes. Yeah. Exactly.
how to do this. Yogesh bhai, if you want the answer.
Okay, so I think so a clear path of that is setting accountabilities कि हाँ भाई ये किसका काम है. बी वेरी क्लियर विद दैट कि हाँ दिस पर्सन इज अकाउंटेबल फॉर दिस पर्सन इज रिस्पॉन्सिबल फॉर दिस. देन अगेन लाइक आई सेड, अगर मल्टी डिसिप्लिनरी टीम में या अलग अलग चीज़ों पे काम करना है तो डिफाइन दोज रिक्वायरमेंट्स कि दिस इज द टारगेट दैट दिस पार्ट हैज़ टू मीट. लेट्स से लैंडिंग गियर है तो उसको ये काम करना है. अगर फ्यूचरलाइज की मैं बात कर रहा हूँ तो उसको ये करना है. मैं विंग्स की बात कर रहा हूँ तो भाई उसको ये विंड कंडीशंस में काम करना है. ठीक है. So have those requirements very clearly defined and then have checks and test at every step. कि अभी क्या हुआ कि अभी तुम लोग अगर बोल नहीं पा रहे हो कि किसकी गलती है तो there is something that you have not tested beforehand. Like so we faced this issue in landing gear development that we were making a very complex part and ultimately it turned out that it had the wrong dimension. I mean we had to rebuild that whole part. And what happened was there were 3-4 processes involved. There was machining, there was honing, there was other plating processes, and they all kept blaming each other. So now looking as a system, I mean, so we somehow rectified that problem, but what we realized was there were no step checks कि वो अभी मशीनिंग हो गया तो उसके बाद वो इंस्पेक्शन हो रहा है वो फॉलो नहीं हो रहा था. So that is what we realized. So in your case, think what is that step that you have missed out, and next time improve on that.
Okay, sir. Thank you so much, sir.
Hi, Nikhil.
Good afternoon, sir. Sir, I am Nikhil Sharma from Thapar Institute of Engineering and Technology, Patiala. Sir, I wanted to ask that suppose we are doing a work on a project and in the final times of the final testing, some major fault occurs. So what should be the steps to be taken as an individual or a team during this situation?
तो शशांक भाई ने इतने अच्छे से बताया तुमको यार, उसका एरर मैच नहीं हो रहा था, स्वाद आ गया था उसको. क्या किया उसने उसके बाद में बताओ. Or is your question different from what Shashank explained? Nikhil, can you elaborate on the question a little bit more or take specific examples?
Yes, sir. Means like I wanted to say that suppose the deadline is just about to get over and in the final time the project gets a fault. So in that duration, what should be done?
Okay. First is see if you can solve the problem. Second is as soon as that fault occurs, communicate. So communicate to your team members, communicate to whoever is the stakeholder, to maybe to your professor, to someone who you are building that project for. So first is get that communication in place because you don't want to be in a situation कि अभी वो time खत्म हो गया and then you are saying that this is a problem that occurred. So So first do that, then see if you can try to solve that problem in that time. Take another learning back to yourself that next time I have to plan, I have to keep some buffer for unknown things happening. COVID was not something that anyone could have planned. These errors occurring is not something you can plan, but you have to have enough buffer in your planning stage that if that occurs, you have enough time to solve those problems. There would still be times when challenges would occur. In those cases, solve that, communicate that.
Thank you, sir.
So, okay, everyone, thanks a lot for being with us for so long. And for us, it was a pleasure to just interact with you guys, and we hope that you take some value out of it. I hope we were not too boring, because for us it is interesting to go into the details, but but maybe it's not for everyone. So sorry if it was too long. Thanks a lot. If you have any questions, personal, related to project or anything, I mean, you can just drop us an email. We will try to answer to you. Baki, it's up to you. Take that lead, develop yourself, keep exploring, and just all the best.
Thank you, Mr. Yogesh and Mr. Shashank, for such a wonderful session. It was very informative. Even I can see from chat messages, they really enjoyed your session. Thank you
Yeah.
so much.
Thanks a lot
Thanks.
for hosting
Thanks a
us.
lot.
So guys, our next session will start at 2:30 p.m. In the meanwhile, you guys can have your lunch.